All right, looking at clouds that are above the level of the ground, what I want to start with first are what are called stratus clouds. These are found in the lower atmosphere. And by lower atmosphere, I mean below, say, 6,500 feet. And so sometimes you'll hear the expression, well, the fog is lifting. Okay? And so essentially what's happening there is that the air molecules are heating up. They're rising up because as they heat up, they become more buoyant. And more buoyant things tend to float, and things that are heavier tend to sink. And so when you heat something up, it can become more buoyant, it can start to rise, and so we get the fog lifting. And so essentially we can think of stratus then as being a lot like a higher level fog. Oftentimes, stratus clouds will cover the entire sky. And tends to cut out a lot of the light, so it's kind of like a yucky day, murky day. You can sort of see through it, but sort of not. Kind of like fog, but a little bit higher up. So it's blocking a good portion of the sunlight that you would be seeing. But you can kind of see through it to a certain extent, to at least a little bit of a distance away. And so associated with stratus clouds then, we can get more of an accumulation of water molecules. These stratus clouds can turn into nimbostratus. Now, nimbostratus clouds tend to extend to higher elevation and have a higher water content. Tend to be darker because the more water content there is in a cloud, the darker the cloud becomes. And it also, because of instabilities that are caused with the rising and the cooling, that, to a certain extent was the rising of the fog produced the stratus clouds, but further heating and rising can give rise to these higher nimbostratus clouds that have a higher water content, are darker and thicker. And so we can see this then on the screen above. Here we have the stratus clouds, which are above the level of the ground, but don't have a huge vertical extent. But if you start to get more and more water content, what will happen is that the water will condense. On these condensation nuclei, but that releases energy. Through condensation, because we're going from a gaseous state to a liquid state. And so that has to release the latent energy that is associated with how much energy it would take to take a certain amount of liquid and turn it into a gas. That takes energy. But when the gas turns into a liquid, that releases energy. And so that energy then can accelerate its upward development. And then it'll cool as it rises. It goes to the point where the temperature starts to drop now at that higher altitude. And because we have this higher moisture content, you often get rain. From these nimbostratus clouds. Okay, so they're kind of a little worse than a murky day because of the higher water content, the upward development, the thickening of these clouds, which releases energy which accelerates the upward motion, that as you get to higher elevation, the temperature drops. So finally you get to the point where you've got all this water that is in the vapor state, but then it condenses, and then it drops out as rain. And so that's what we tend to see then with these nimbostratus clouds up here. And so these are clouds then that are still found in the lower atmosphere. Going to more unstable clouds, ones that tend to rise quickly, we have what are called cumulus clouds. So these cumulus clouds tend to rise and expand. Now, why does this happen? Well, first of all, the cumulus clouds tend to be more buoyant. So there are updrafts. But as one of these cumulus clouds moves upward, it tends to expand. Why does it tend to expand? The reason is that there's lower pressure as you go to higher elevation. With less pressure, the cloud that it was at a higher pressure at lower elevation is naturally going to tend to expand. But the expansion takes energy. And so where does it get that energy? Go, well, hey, could I borrow some energy from this air over here? And that air over there that's outside of the cloud says, sorry, I don't have time to give you any energy right now. I'm busy. And so the cloud then doesn't have time, because it's expanding rapidly, doesn't have time to absorb the energy from the outside. So it says to its own molecules, can I borrow some internal energy? And the molecules say, well, I don't know about that. That's going to drop my temperature. He goes, please, I've got to expand. There's nothing I can do about it. And he goes, well, okay, I guess so. And so this thing expands and cools. Now, if you don't believe that this happens, what I'd like you to try to do for a second, because nobody else is watching you, is to take a deep breath and blow on your hand, but keep your hand close to your mouth, like this. And now move your hand away, but keep blowing. Do you feel it warm at first, but then getting colder? as you move away, the farther away you move, the cooler it gets. That's because the warmer air that's coming out of your mouth hasn't had time to expand yet. But by the time it hits your hand here, the warm air expands and cools. And that's why the air on your hand feels cool farther out. But it feels warm, you do it right next to your hand. But then very quickly, feels like it's getting cooler as you move farther out. So that's what's called adiabatic expansion. And so that's essentially just the cloud asking to borrow internal energy for my expansion. And so the cloud then tends to expand and cool. Now once it cools to a certain point, then its upward development usually stops. So we can see on the upper screen the kind of thing that's happening then with these cumulus clouds. Okay, these cumulus clouds have some vertical development that's associated with this expansion, and this cooling is what finally causes them to settle down and not want to expand any farther. However, if we go to a more unstable kind of a cloud called a cumulonimbus, this is an unstable cloud that has much more energy, much stronger updrafts, and a lot more water content. So it's got more of everything. Now as it cools, this causes the water to dump out, so we get rain. But this tends to happen very quickly. So it's upwardly unstable, whereas a cumulostratus cloud tends to be unstable up to a point, but then it kind of peaks out. The cumulonimbus is a thunderhead. So this happens very quickly, it expands rapidly, and its upward development is associated with a very rapid expansion. And so associated with that, we mentioned this before when we were first talking about the atmosphere, that these things can form an anvil-shaped top. Okay? And so this then is the tropopause, which is the boundary between the troposphere and the stratosphere. We have a temperature inversion here, which we've talked about before, which blocks the upward motion of the thunderhead. And so these clouds then can move up through the different levels of the troposphere and then are stopped before they can move into the stratosphere by the temperature inversion that's associated with that. This is associated with lightning and lots of rain. and maybe even some cyclonic activity, even tornadoes can happen with these very unstable kinds of cumulonimbus clouds. Now, as we move to higher elevation, say above 6,500 feet, but less than 20,000, we're up in the middle atmosphere. And we have different kinds of clouds out there, but they have some similarity to the clouds that we see lower. So here we're at maybe 6,500, typically to maybe 20,000 feet. And so in this middle atmosphere range, over here with the clouds that have a certain amount of stability, we have the alto cumulus clouds. Now, alto means high up in Spanish. So alto cumulus is like the cumulus clouds that we see at lower elevation, but more broken up. These are basically just more fragmented cumulus clouds. And so if you see something that looks like a cumulus cloud, but maybe more broken up, then you're probably looking at something that comes from the middle of the atmosphere. So we can see if we look at this more carefully, how this looks a lot like our cumulus clouds here, but more broken up. So it has a similar kind of a composition, and sometimes it looks like a bunch of little tiny cumulus clouds here. And so that is one of the things that is found in the upper atmosphere. Also, we have altostratus. So remember that our stratus clouds are basically thicker down below, but somewhat uniform in composition. Here's thinner, but somewhat uniform in composition. And so you could probably see the sun through alto stratus clouds, but you couldn't see the sun through just regular stratus clouds because they'd be thicker down near the surface, but less thick. These would be our less thick stratus clouds in the middle atmosphere, with the sun being able to be seen through them. Indicating that since that couldn't happen with the stratus clouds that are lower down, or if the sun were visible, we would just barely be able to see it at all. That the sun would be visible, but you might be able to look at it for a second without experiencing too much in the way of discomfort to the eyes. And so that's mostly in the middle atmosphere. Of course, you can have the cumulonimbus clouds extend up through this middle atmosphere. But then finally, when we get to the upper atmosphere, we have the cirrus clouds. So these are like stratus clouds that are really thinned out. This is up 20,000 and above. So our altostratus clouds were even more thinned out than the stratus clouds at the surface. But the cirrus clouds you could think of as being the most thinned out of all. So also you have the cirrocumulus clouds. And these cirrocumulus clouds look very much like cumulus clouds at a lower elevation that here, even more fragmented. So here are cirrocumulus up here. And so sometimes, because this is even more fragmented than the altocumulus clouds, we call it a mackerel sky. And of course, there are many different variations of these different cloud forms. Just to look quickly here at a few examples of each one of these, we have the cumulus clouds in this picture. Okay, so these are the big fluffy white clouds. Oftentimes you see these in beautiful pictures. And what you'll notice with these cumulus clouds is that they're often kind of white, but they may have little dark regions within them. And those dark regions are associated with higher water content. And so you can, if it looks a little more stormy, then you might have a larger portion of the cumulus clouds would be dark. And then they can turn from one type of cloud into another if the conditions are right. This could turn, for example, into nimbostratus. Going over here, we have stratocumulus. And so that then is like our cumulus clouds, but higher elevation. Here we have altocumulus there. Here we have cirrostratus. Okay, so this is in the very high regions of the higher regions of the atmosphere. Here we have the cirrus clouds that we talked about in the upper atmosphere. And here we have the cirrocumulus clouds, which are associated with the mackerel sky.